Hello everyone, it's Asat Games. Today I will be showing how you can develop a top-down shooter game with Defold. I will share this project on my itch.io page. You can download it from there. I will leave the link to the comment section. Before we start, I will show you the game we will be developing. I will add timestamps to the video so you can skip it if you want. This will be the game we will be developing. This is our main menu. We have our settings. We can turn the sound on and off. We can change the difficulty. Let's play the hard and we can start the game. This is our player. We can shoot. We can switch between weapons. There are loot boxes. We can collect them. We have enemies which follow the player and attack. We can throw grenades to the enemy. We are now on the second level. If we die, we can replay the level. We have decals. When we reach the end, we finish the game. So we can start a new game or return to menu and restart the game. This will basically be the game we will be developing. Now let's see how we can develop the game. As you can see, my panels are toggled off. We can use F6, F7 and F8 to toggle them on. For this, there are a few things we need to do with the game.project file. We first need to add a dependency, which is for the A-star algorithm. It is from Selim Anac. And if you go to the credits file, you can see the library link. You need to copy this, go to the game.project, press plus, and paste it here. After that, you need to go to project and fetch libraries. So the library will be added to your project. Now, before starting, you can again go to game.project and go to graphics. On it, if you are going to use pixel art, you can select nearest. So pixels will look sharp instead of blurry. After that, you can start with creating the folders. Right click, new folder, name it assets, and add another one for resources, scripts, and sound. If you download this project, you will have them already, but if you are going to use an empty project, you need to drag and drop your files you want to use on the game on these folders. You can right click, show in desktop, and copy and paste the files you want to use in it. But to use them, we will need either tile sources or atlas. We have one image atlas, a portal tile source, tile map tile source, and other tile source. We use atlas when we have image separately, like here, this button is just one image. But if you have an image with many sprites, then you need to use tile source. So first, right click New Atlas and name it Image Atlas. On the Image Atlas, right click Add Image and select the image you want to add. For the tile sources, right click New Tile Source. Name it Portal.tileSource. And on the tile source, you need to select the correct image. Find the portal. It is 32 by 32, so set the tile width and height. For the tile map, again, right click, new tile source, name it tilemap.tileSource. Select the tile set image. Now we want to be able to collide with tile map, so we will need to add some collision to our tile source. For this, you can right click, add a collision group, name it default, and while default is selected, if you press on a tile, default will automatically add the collision shape, but we only want to collide with the walls, not the tiles on the ground. We also have an animation, so you can add an animation. I named it BG for background, and it shows the tile 30. It doesn't have any animation, so playback is set to none. On the other tile source, you can again right click and create a tile source. This time we will be using this for animations. So we add a bunch of animations. We have a pistol, machine gun, shotgun. For the first three tiles, they don't have any playback, so they are set to none. We have muzzle flash for big and small. We have a grenade. The only real animation here is explosion, which starts at the tile 10 and ends at tile 12. So we set the correct start and end tiles. On the animation, if you press space on the explosion, you will see the explosion playing. If it is too fast, you can drop the FPS. If it is too slow, you can increase it. Even though these sprites do not have any animation, we still add them as animations. So when we need them, we will be able to use sprite to change the sprite we are using. We don't need to do this with Atlas because on Atlas you can just select the image after attaching it. But on a tile source, if you want to be able to use a tile, then you need to set it as an animation. After we set our tile source and Atlas, we will be able to use them. So now we want to create our tile map. For this, let's create a tile map. Right click, new tile map. Name it level 1 tile map. On the tile map, you can add a layer with A. We will have two layers. One is ground and the other is walls. On the tile map, select the correct tile source, which is our tile map tile source. While the ground layer selected, if you press space, you will see the tile map. Select the ground you want to add and design the level as you like. On the walls, if you press space, you can select a wall and draw it. After you are done with designing the level, you can copy with Ctrl+C and paste with Ctrl+V and name the new tile map as level 2 tile map. On the level 2 tile map, you can change the map. We will be starting here and game ends here. It again has the ground and walls. You can draw them as you like. I created some simple levels to demonstrate the project. After this, we are done with tile maps, tile sources, and atlases. Now on the resources, we can create another folder, name it objects, and we can create a bunch of objects on it. Let's first take a look at the blood decal. This is a simple game object which only has a sprite. To create a game object, on the objects folder, right-click, new game object, name it blood decal. On the game object, right-click, add component, select sprite, and on the sprite, for the image part, select our image atlas because our blood decal was on our image atlas. On the default animation, select the decal. I only have one decal type, but with your game, you can add a bunch of them, and when spawning a decal, you can randomly select one of them to have a variety on your game. After that, we have our bullet game object. Right-click, new game object, name it bullet. On the bullet, we will have three things. One is our script, the second one is the collision object, and the third one is sprite. For now, I will not explain how these scripts work. I will explain them after I explain how you can create these objects and how you can create the GUI and the collections we will be using with the game. So for now, you just need to create the game object, add the components it needs. After we are done with the game objects, I will show you the scripts. Then, after you have the scripts, you can right-click, add component file, and select the script you want to add to the game object. So right now, let's take a look at other game components. First, right-click, add component, select sprite. On the sprite, select the other.tile source because that is where our bullet was at, and this is why we set images as animations on the tile source, so we can select them as default animation. Select the bullet. You can scale it up or down as you like. Then we will need a collision object, so right click, add component, select collision object. On the collision object, right click, add shape, select a box. On the box, set the dimension size as you like. Now on the collision object, we need to set the type to trigger. It will be dynamic at first because we want the bullet to trigger some effect on the enemy or the player. Now scroll down and on the group, set the name to bullet and set the mask as default player and enemy. You can only have one group, but on your mask, you can look for many groups. Group is where you are. We are on the bullet group or layer, we can say. And mask is what group or layers we interact with. We will interact with default layer because we want the bullet to know when it hits to the tile map, so it can delete itself. We want to know if we have collided with player or enemy, so we can reduce their HP. And that's it with the bullet game object. I will skip the enemy and player for now. Now we have our grenade game object. For this again, create a new game object, name it grenade. Grenade has two sprites, so for this right click and component, select sprite. The first sprite will be the grenade sprite, so select the correct tile source and set the grenade animation. The second one will be for explosion, so add another sprite and set the correct tile source and animation. We will have two collisions too. For this, add a collision object. The first one will stay as dynamic. It is this small circle, and this will allow the grenade game object to interact with the tile map too, because tile map is on the default group. So it will collide with the tile map when you throw it and will not go through walls. On the collision object, you can add a sphere shape, set its diameter as you like. For the second collision object, add another one, name it range, and set the type to trigger. This will be the range where enemies will reduce HP if they are in. So we need to be able to detect enemies. So we will be on the group of grenade and we will be seeing only enemies. We also have a sound component. So for this, right click, add component, select sound. On the sound, we will select the explosion sound. On my sound folder, I have sound files and they all are OGG files because with default you can't use MP3 sound files. So you need to convert them into OGG. You can use Audacity for this. I have a tutorial on how you can convert MP3 files to OGG. So you can watch it and convert your sound files to OGG too if you need. With this, grenade is also done. Then we have our loot box. For this again, add a new game object, name it loot box. On the loot box, right click, add component, select sprite, and select the correct tile source. For this, we have two animation. One is box closed and the other one is box open. I will start at box close, and when player collects the loot in it, we will change it to box open. But let's start with closed. We have a collision object, so add the collision object. Set it to trigger because it will need to be triggered when player collides with it. It will be on the group of bugs and it will see the player, so enemies cannot collect it. You can add a box and set its size as you like. We have our loot box script, which I will explain later. We have our sound component. For this, you can add a sound component. I have a collect.ogg file, which will be played when we collect the loot. We have a looping option. If you select this one, the sound will be looping, but we don't want this. You will be using this mostly with background music. As you can see, sound is also on the master group. When you add a new sound component, it will be automatically in the master group, and we will be using when we turn the sound on and off on the menu. We have our portal game object. You can create a new game object for it, name it portal. You can add a sprite. On the sprite, select the portal tile source because it has its own tile source. It only has one default animation. On the sprite, if you press space, you will see the animation being played. And you can use this arrow to go to the tile source so you can change the FPS as you like. We have a collision object to detect the player, so we add a collision object, set it to trigger because our goal is not to stop the player from entering here, but we need to detect when player enters, so it will be triggered. We are on the group default and we see the player. We have a sound component, add a sound component, select the correct sound you want to use. It will not be looping on the group of master. We also have a mouse cursor game object. For this, again, create a new game object, name it mouse cursor, add a sprite. On the sprite, select the correct animation and image you want to use. We will use this as a cursor that will follow our mouse. It has its own script. I will also explain it later. Now I will explain the player game object. On the player game object, right click, add component, select sprite, and we will add a sprite, name it player sprite. On it, select the atlas and set the character 1. Then add another sprite, name it gun sprite. Use W to be able to move it around and put it on the hand. We have pistol, shotgun, and machine gun. Now for this, I have also added another two sprites. One is muzzle flash big and the other one is muzzle flash small. That's because on the gun sprite, if I select pistol, the small muzzle flash looks better. But if on the gun sprite, I select the machine gun or shotgun, then the muzzle flash big looks better. With default, we can't set the position of sprites via script. So as a way around, I have added two muzzle flash and set them accordingly. When firing, we will be showing and hiding them very quickly, so it will look like a fire effect. After you are done with the sprites, you can add 3 collision object, right click, add component, select collision object. Arm and body collision will be dynamic collision shapes. These will stop us from walking through walls. On the arm and body collision, add the correct shape you want to add. You can use W to see these arrows and move it around. You can set its dimensions as you like. You can do this for both arm and body collision. Then we will also need a trigger collision object. So for the third collision object, set the type to trigger. We will be on the player group and we will see the default, box, enemy, and bullet. This trigger collision object will allow us to interact with the world, like getting hit by bullets, collecting loot boxes, using portal, etc. If you want the portal to has its own collision group, let's say you set this to portal, then on the player we will also need to add it here. Since we have 3 gun types, machine gun, shotgun, and pistol, we also need 3 sound components, so right click, add component, select sound. You can copy and paste it 2 times to have 3 of them. Name first of them as pistol, set the pistol sound. Do the same with rifle and shotgun. If you press these 3 dots, you will only see the OGG files. We have our script, which I will explain later, but other than that, we also have 2 factories. With default, if you want to spawn a game object, you will need factories to spawn them. So we first add a component and select factory. On the factory, name it bullet factory and select the bullet game object. Do it again, add a component, select factory, name it grenade factory and set the prototype as grenade. So when you use factory.create, you will be creating the game object you set here as prototype. And with this, we are done with the player. Now on the player, you can Ctrl+C and V to copy it. You can right click, rename it, or press F2 to rename it. Rename it as enemy to avoid doing this all over again. Because with the enemy, we again will have arm collision, and body trigger. You don't need to change anything with the arm and body collisions. On the body trigger, scroll down, set the group to enemy, and enemy will only interact with default, bullet, and grenade. I tried to keep the game simple so enemies will not be able to throw grenades. So you can delete the grenade factory, bullet factory will stay as it is. It has its own script, so you can delete the player script and right click, add component file and select the enemy script. You can name the sprite as enemy sprite. Select the character too, so it will look different from the player. Again, with the game, enemies only use pistols, so I have deleted the muzzle flash big. But if with your game you want them to have different kind of weapons, you can keep it. And additionally, we have another collision object. For this, again, right click and component, select collision object. Set the type to trigger. On it, add shape, add sphere. Set its diameter as you like. This will be the range where enemy can detect the player. It will be on the group of enemy and it will only see the player. With this, we are done with creating the game objects. Now we need to set up our scenes. With default, the game first loads the main collection. So if you want to play a level on your game, you will need to load it here. On the main collection, you can right click, add a game object and name it scene parent. On the scene parent, we will have a script to handle scene management, and we will also have collection proxies. For this, right click, add component, select collection proxy, select the collections you want to use if you have them. If you don't have them, you can add them later. On my game, I will have level 1, level 2 and menu collections. Since I already have the collections, I have selected them. But if you don't have it, you can add it later. Then again, add component file to attach the scene parent script. Now we will need some collections for levels. So first, let's start with the level 1. On the main folder, right click, new collection, name it level 1. This is how my level looks like. First, I have my background game object. For this, you can add a game object. On the background, I only have a sprite component, and on the sprite, I have select the tile map tile source and select the BG as animation. If you remember, BG was the tile 13 here. So I just used it and scaled it up by a lot to cover the whole screen to have a proper background outside of the tile map. On the collection, we also need another game object. Name it camera parent. On the camera parent, right click, add component, select camera. On the camera, set the orthographic projection. I have set the zoom to 2 to see the game better. If it is fun and I play the game, everything will be small, so I increase the zoom to see the game better. It is a simple script. After the camera parent, we also need a decal parent game object. So add another game object, name it decal parent. On it, right click, add component and select factory because we will be using it to create the blood decal game object. If you want to have a variety of game objects, you can add more factories here and select one of them randomly on the script. Again, add a game object, name it tile map. On the tile map, right click, add component file and select the level 1 tile map because this is the level 1. Then we also want to be able to collide with the tile map, so it needs a collision object. Add a collision object. For the collision shape, select the level 1 tile map. Set the type to static, so it will not move around. If you set it to dynamic and collide with it, you will be able to push the map around. On our group, we will be on the default group and we will see the default player, bullet and grenade. Also, I just remembered, go to game project, search for gravity, and on the gravity Y, set the value to 0. Otherwise, your dynamic collision shapes will fall downward, and we don't want this to happen with our top-down game. It is only necessary if you are developing a platformer. Since we have our tile map, now we can place our enemies. So add a game object, name it enemies. We use this to keep the scene organized. So on the enemies game object, right click, select add game object file, and select the enemy game object you want to add. You can click on an enemy, press W to see the arrows and move it around. You can add as many enemies as you want to your game. Then add another game object, name it loot boxes, and right click, add game object file, and select loot box. You can again move them around. Now, if you have noticed, some arrows are blue while the others are gray. Blue means something has been modified on the game object. If I check components under the loot box, we will see the script is blue, that means something on the script is changed. On the script, we have a type and value. They are set to 0 at first. It is gray when it is 0. Loot box will have different loots, different bullet types, grenade and HP. So we will be using this to set some type and value to it. And this is similar to the export option on the Godot. You can move the loot boxes around, you can change the values as you want. After you are done with the loot boxes, let's add another game object, name it music. Under the music, add a sound component. This will be the game music that is being played. We select the looping as true. We don't want it to stop after playing once. It is on the master group. We can also add our player, so right click, add game object file and add player. Move it around, player will start here. We will be adding a portal to the level because portals will be used to move between levels. We need another game object for the mouse cursor, so right click, add game object file and select the mouse cursor. Lastly, we will have our GUI. For the GUI, you can right click, add component file and select the GUI. If you don't have it yet, you can add it here after we are done with creating the GUI. Since level 1 is done, we can just Ctrl C and V, copy and paste the level 1 and name it as level 2. On it, you can go to tile map, select the level 2 tile map, and on the collision object also make sure to select the level 2 tile map. So level will be updated. You can move your enemies around to fit the new level. You can again move around the loot boxes. You can change their values. Other than that, everything should work fine. We also changed the portal script because this is the level we want to move on. We want to go to the level 2, so we have the 2 as the value, and on the second level's portal, we have the goal level as 3. This 3 will not actually take us to level 3 because we don't have it, but we will know we have just beaten the game. And of course, it's all handled on the script, which I will explain after I show you how you can create the GUI. Right click, new GUI, name it GUI. After you have created it, you will need to add some fonts to be able to use text. So right click, add fonts. I will only use the built-in font. To be able to use images, you also need to add them as textures. So right click, add textures, select image atlas because it has our UI elements. Then also do the same for other because it has our gun sprites. After you have added the textures and fonts, the rest will be done on the notes part. Let's first hide the screens. First, we will be adding a few things. We have a text here where we tell the player what he has collected. We have 2 boxes here for the HP bar. We have a box for grenade and 1 text for grenade amount. We have 2 boxes here. One is for the gun player is currently using, and the second one is to show the bullet image. This is for the bullet text, shows how many bullet player has for the gun shown here. To add a note, you can right click, add a box by text template or particle effects. We will be using simple box and text here. This will be our HP out, name it HP out. Select the HP out texture. Now this is too small, so we will scale it up by, let's say, 5. Or it's better, I guess. Yeah. Now I don't want this to be a square, but a rectangle. So I need to change the size mode to manual, and I will increase the X size to 64, let's say. But now the sides will be stretched out, and we don't want this. So go down on the slice 9, set the values as 6 maybe. Now if you look at this, 6 is too much, 3 could be better. When you change the size, the middle part will be stretching to all directions. You can use this to create an HP bar. Now we have our HP bar out. It is scaled by 4. It has size as 96 to 16. It has 3 as the slice 9 values. After you are done with this, you can Ctrl C and V to paste it. Name it HP in. And on the HP in, select the HP bar in as the texture. When you first edit, its pivot will be center. And let's move it to here. So when you change the size on the X, it will approach to the center, while we want it to approach to the left. We go to the pivot, set it to west, move it to left, and now if you change the size, it will act properly as an HP bar. For the loot text, you can right click, add text, and name it loot text. On the loot text, you can change the color. You need to select the font, otherwise it will throw an error. The text will be set from the script. We don't have a font size option, so what you need to do if you want to change the font size is to change the scale of it. Then we can add the grenade image. So right click, add box, select the grenade texture, scale it up by 4, move it around, and place it where you want it to be. For the grenade amount text, right click, add text, name it grenade. We don't need to change the name of this grenade image because we will not be changing it. So it will stay as box, but we will be changing this text. So set the name to grenade, change the color as you like, and scale it by 3. Do the same for gun. Add the box, move it here, set the correct texture, scale it by 4. If you want to apply some color to it, you can still change the color of it and it will be applied as a filter. You can use this for locked items on your game. Since we will be changing the sprite here when player switch between weapons, we need to set it a proper name because we access the nodes with their name, so set the name as gun. But for the bullet, we just need to edit for show, but we won't be accessing it. For the bullet text, you can copy and paste the grenade text, move it, name it as bullet, and change the color. And that's it for the basic UI. Now we have 2 screens. One is the loose screen and the other one is win screen. We can first create the loose screen and copy and paste, then modify it to have a win screen. For the loose screen, we have everything under a box, so when we hide the box, you will not see any of them. So it is easier than hiding each of them one by one. So right click, add box, name it loose screen, select the correct texture you want to use. It has slice 9 values as 12, set its color here. My game resolution is 960 to 640. So you can actually have the scale as 1 and set this to 960 to 640 here. But now the borders will be extremely small and we won't be able to see it. So what you can do is to scale this by 5 and divide the size by 5, you can just put slash and 5 to divide it, and Defold will handle the calculation. Now it looks better. Right click, add text. On the text, set the text as you have lost, try again, or whatever you like. You can change the color. If it is too large, you can scale it down. Now we will have 2 buttons here. For buttons, we will be using boxes again. Add a new box to the loose screen. Select the box closed texture. On the box, add a text. Set the text here. Change the scale here. Change the color if you want. Copy and paste this. Move to the left. Name it Try Again. Change the text here. After you are done with the loose screen, Ctrl C and V to copy and paste. Change the name to Win Screen. You can't have 2 nodes with the same name, even if they are on a different level of the hierarchy, because with Defold we access the nodes using their name. So if you have 2 nodes with the same name, system will not know which nodes to access. So all nodes will have different names. On the Win screen, what you can do is change the color. You can change the text here. Congratulations, you have cleared the game. We need to change the return menu button's name because we already have one under the loose screen, so we can't have another one here. So I used return menu 1. Then we have a start again button. This starts from the level 1. And that's it. That's how you can have your GUI. Now with GUI, we don't right click and attach the script. It already has its own slot for script. So when you have the GUI script for the GUI, you will need to click these 3 dots and select the GUI script. Lastly, we have our main menu GUI. Similar to the GUI, add the font by right clicking and adding, add the textures. Now on the nodes, we have a layer system here. We have a background, an image that doesn't change, and we have 2 layers. One is the base layer. This is what we will see at the start, and we have a settings layer for the settings. Now for the base layer, right click, add box, set the name as base layer. Since our background image is already there, we don't actually have any texture set on the base layer, and it is enabled visible, but its alpha value is set to 0. If I set this to 1, as you can see, it is actually a box on the bottom left corner. I set this to 0 because I don't want this to be visible. Its only purpose is to stay as the parent of the nodes under it, so we can easily access and toggle them. Now when you first do this, anything under the base layer will also be invisible because it will have the inherit alpha selected. So when you change the alpha to 0, you will see the nodes under it also disappear. To avoid this, you can just go and toggle off the inherit alpha value. So it will has its own alpha value, and since it is on 1, you will be able to see it again. So base layer is basically an empty shell. On the base layer, right click, add a box, set the name to start button, select the button texture, set the size scale, set the size mode to manual, use a size 9 with value as 8, copy and paste it and move downwards. For the exit button, name it exit button, add a text that says exit, do the same for the settings, then add a new text, set the text to top-down shooter. Since base layer is done, copy and paste it. name it as settings there. What is different is we deleted the title here. This is all you need to do. The rest will be handled on the GUI script. It has its own main menu.gui script. So when you are done with scripts, you will come to this main menu GUI, click these three dots and select the main menu GUI. Now, if you have noticed, we have a collection named main menu, but we don't have one for GUI. That's because we use the GUI on an already existing collection on the levels, so we don't need a separate collection, but we want our main menu to exist on its own, so we will be able to load it without loading the game. To do this, we will create a new collection, name it main menu collection, and it will have two game objects. Right click, add a game object. The first one, you don't need to change the name, just right click, add component file, and select the main menu GUI. With this, we will have our GUI. Now we have another game object named music. So right click, add a game object, name it music. Under it, add component, select sound, and for the sound, select the menu music. I forgot to loop it. Select the looping. It is again on the master group. With this, we will be able to use main menu as a scene. Now, if I go back to my main collection, since we have our collections, we can also set the collections to level 1, set the level 2, set the menu. This is why we need a main menu as separate collection. And with this, we are done with everything other than the scripts. Since we are done with the first part, now we can continue with scripts. We will have three types of script. One will be GUI scripts. These will be attached to GUI and the main menu. We will have modules. Modules are public classes, so we will be using their variables and functions from different scripts. And these are the scripts we attach to our game objects and handle the game logic. Let's first start with the modules. I will start with camera.lua. Camera module, not my script. I have found this on Defold forum, and we will be using this function here. This function basically converts a vector on the screen to the world coordinates. So when we move our mouse, we will know when the mouse stands on the world using this function. Then we have our game manager module. This is the main public class, we can say, and it has many variables we will be using through the game. We first create a table named M, and on the table we have a bunch of variables. The first one is sound on. We will be using this from the main menu when we turn on and off the sound. We have a difficulty setting. We will be changing this again from the main menu. We have a current level variable which we use on the scene parent to know which scene to load or unload. We have our HP, max HP, grenade amount, and weapon number. Weapon number is which weapon the player is holding. So 1 is pistol, 2 is rifle, and the third one is shotgun. We also have an empty weapons table. We will fill this table using this default weapons table. And we also have another empty table named save data. We will have a bunch of functions here. We have a save progress, load save, and reset game. Let's start with reset game. We will call this at the beginning of the game on the level 1, or after we win the game and want to restart from the beginning. Here we set the values as their initial values. HP is set back to 75, max HP is 100, and so on. We empty the save data and use save progress function to fill this one. We also have our weapons table. We use deep copy helper function to copy the default weapons table. We don't just say default weapons here, because then more than one table could point to the same table, and this could cause some problems. For this, we are copying the table. This deep copy function uses recursion, so calls itself, and copies all of the table. For example, this is a table which has tables under it, and you could have another table as the bullet amount, let's say. So when we copy them, we need to check recursively for each table as a whole table. We have a save progress function which we call after we finish a level. So when we finish the level 1 and use the portal to switch to the level 2, we first save the progress, and after we load the level 2, we load the save. The save data has some variables like current level, HP, max HP, and we just take them from our M table at the beginning. So you can think this of as a temporary table. When loading, after we load the level 2, we get the data from the saved data and check if there is actually any data saved, because we don't want to load an empty table. Then we set the data from the saved data. We also make sure to check if the data exists. If not, we use the original data. And again, for the weapons, we use deep copy to copy the default weapons table. And this is basically the game manager. And we look at the other scripts, we will see how many times we actually access this one. Lastly, we have our A-star Lua module. This module uses this A-star library and handles the necessary steps we need to take for enemies to be able to move around and find their ways. We have a local variable named initialized. When this setup A-star function is called, we check if we have already initialized. That means we already have a map of the tile map where enemies can walk on. So we don't need to do the whole calculation again. If not, we first set it true, so it will not be calculated again. And continue. We will be calling this from the enemy script. So if you have 100 enemies on your map and you don't add this check, that means you will do these calculations 100 times. These parts are unnecessary. Let me change them. Okay, so we first create an empty table named map, and we get the tiles from our tile map using tilemap.getTiles, and we put the tile map's path and the layer we want to get the tiles from. Then we iterate through the whole table to execute this part. Here we create a local variable named tile, and we check if this exists, and we get the correct tile number. This part is just an additional check. We don't need it. This can stay like this. When you use tilemap.getTiles, it returns a table with the ID of the tiles as values. Let me show you what I mean. If I go to my tilemap tile source, if you look to the top left corner, you will see that each tile has its own ID. It starts from 1 to 30. When we use tilemap.getTiles, it will return the values corresponding to the tile we draw. So if the tile is this one, let's say the tile 50 to 25 is this gray tile, that means 50 to 25 will return 26 because it's the 26th tile. Then we check if the tile is 26, 27 or 28, because these are the 3 tiles we will be able to walk on. If you have more, you can just edit here. If we can walk on it, then we insert it to the table with the value of 1 to mark it as walkable. If not, we edit with 0 to show it is non-walkable. Then we have this part, which is more of the formality part. I will not be explaining, but this part may be important. If you want your enemies or AI to be able to move diagonally, then you will need to have A*.direction8. But if you only want to be able to move horizontally or vertically, then you can use direction 4 too, but direction 8 is better for this case. After that, we use a star.setCost to set the cost, and with this we have set our a star. Then we have another function which is findPath function. It gets an start and end position. These are not vectors on the world, but they are the corresponding tiles of the world coordinate, like the one I said, tile 50 to 25. And we also do the same for the end. We check if there is a path from the start to the end position. We use a star.solve to solve this question, and it returns some values. It returns status, size, total cost, and path. We check if the status is solved. If that is the case, that means there is a solution. So we create an empty table named waypoints, and we get the tile from the path we have found here, and save the tile coordinates to the waypoints as x and y values. After we are done with this for loop, we then return the waypoints and the total cost. If the status is no solution, we just print no solution. If status is start and same, that means it has actually reached where it needs to be. So we don't need to move, we just print this statement again. If neither of these statements hold, then we return as nil. We have another function that says set initialized false. As you remember, we have set the initialized here as true, but when we load a new level, this value will stay as true because this is not a script but a module, and this is public. Just because you reload a level, it will not be reset. So we create a function to reset it and call it when we are loading a new level. This return ensures when we use findPath from other scripts, it will correspond to this findPath here, and same with the followings. This is how the A star part works. We will see the continuation of this on the enemy script. Now we are done with Lua modules. So we can continue with GUI scripts maybe. Let's go to our main menu GUI. Here we only have two functions. One is init and the second one is on input. Let's take a look at the main menu GUI. Now if I use F6 to toggle off the left and F8 to toggle on the right, we will be able to see things better. Let's see the nodes. On the main menu GUI script, we require Game Manager module. If you want to use a module on a script or a GUI script, you need to add it like this. We will be using the Game Manager for difficulty settings and the sound setting. On the init, the first line is acquire input focus. When you add this line, the script checks for inputs, so you can use the on input function. For the other scripts where your input doesn't make any difference, like the enemy, whether you press a key or not, enemy will not be affected, so enemy does not need this line. We start playing the music.sound. You can use sound.play to play a music on the path of the sound component you have stayed here. We have a music game object and sound component here. So we are basically accessing this and using play to play it. And you can set some values on it. We send on a table 4 values: delay, gain, pan, and speed. Delay is 0, we want it to start right away. The gain is how loud it's going to be. Since I don't want it to be loud, I set it to 0.1. Pan is how much it is going to focus on the right or left ear. We can keep it as 0. Then the speed is how fast it is going to be played. We will set it as 1. Then we start saving the nodes of the main menu. On our set table, we create a variable named base layer and we use GUI.getNode and enter base layer here. You need to use the same name you have here, so you can copy it and paste it. We do the same for settings layer, start button, exit button, settings button, sound button, difficulty setting button, and return menu button. We can use GUI.getNode and the name of the node to get the nodes. We also get the difficulty text and sound text. Then we have a new variable named current layer and set it as base. We need this because on the main menu we have some layers. Even if I hide the settings layer, as you can see, the buttons are still there. So if I click here and check for the clicks on that position, then the games will say, yes, you have clicked that button, even if it is hidden. We don't want this happen. So we will have a variable named current layer. If our current layer is base, only then these three buttons, the ones we can see, will be pressed. If we are on the settings layer, then only the setting buttons will be available. You can use GUI.setEnable to hide and show a node. Since these nodes are under the base layer, we can enable and disable it to show it all. We use it with the base layer and set the value as true to show it. We do the same with settings layer, but use false to hide it. We then create a new table on our self table named difficulty levels. It goes as easy, normal, and hard, and difficulty index is 1, which means we are on easy. If we increase the difficulty index to 2, then it will be normal, and hard it will go on. On input, we check for a bunch of things. If I go to my game.input-binding file, you will see that I have a bunch of key triggers and mouse triggers. If you want to add a new trigger, you can press space and select the button you want to add, let's say B, and it will be for bump. You can add them as you need. I have WASD for movement, up, left, down, and right, and R to reload. We can use this to reload a level we are on. Button left and button right for left and right click. We have wheel up and wheel down for scroll up and down. These are the action names we need to check for, and as you can see here, we check for the left click. Now if we go back to the onInput function on the main menu GUI, we check if the left click is pressed. Adding this, make sure we call this part only once per one click, because when you click once, even if you do it fast, you are actually holding it for a few frames, and if you don't add this, then this part will be called more than once, and most of the time it causes some problem with the game logic. So make sure to add it unless you don't need it, which we will avoid using with the player's shooting mechanic. If we are in this if statement, that means we have just clicked, and we can check for our current layer. If our current layer is base, that means we should only be able to click to the start, settings, and exit buttons. When clicked, if you want to be able to tell where I have clicked, whether if I have clicked on this button, then you can use GUI.pickNode and first send the node you have, then send the action position where you have clicked to the function. If when you clicked it was on a button, this will return true. That means you have just clicked the button. For this case, it is start button. If we have pressed the start button, then we need to change the scene. So we send a message to the scene parent that says change scene, and the scene we want to be on is the level 1. When developing a game with Defold, you need to get familiar with message.post, because we use messages between objects to communicate. You can't directly call a function from the scene parent unless it is a module, but you can send it a message. When the message is received, it will have a value named scene, and it will correspond to level 1. If where we clicked is not on the start button, Then we check if it is on the exit button. If it is, we use os.exit to close the game. And we also check if we have clicked the settings button. If yes, that means we need to change our layer from base to settings. This is what we need to do. We need to disable the base layer and enable the settings layer. So we use GUI.setEnabled with base layer and send false as the value. So this will hide it. And we do the same with settings layer but send true. So it will be shown, and we will also set the current layer to settings. So next time when we click, we will ignore this and check if we are on the settings layer. If we are on the settings layer, we will need to check three buttons: sound button, difficulty setting button, and return menu button. If the sound button is clicked, then we reverse the game manager is sound on. If it is on, we set it to off, and vice versa. If after changing it, game manager.is sound on is true, that means we need to play the sound. So we first set the text to sound on and let the player know sound is on. Then we use sound.setGroupGain with master and as the value of 1. If you remember, gain was how loud the sound is going to be. So when you set a group's gain to 1, we will be able to hear it. But if the sound is off after we toggle this, then we set the group's gain to 0. If you remember, all of the sounds we have was on the master group, so setting it to 1 or 0 basically turns the sound on and off. If where we clicked is not on the sound button, we can also check for the difficulty setting button. If we have clicked on it, then we first increase the difficulty index. It was 1 at first. If we increase it, it will be 2. So now it corresponds to normal. But if we are already on 3 and we increase it, it will be 4. That means we need to actually go back to 1. So here what we do, we check if the current index is greater than the difficulty levels table's size. If you put a sharp before a table, then this returns the size of the table. So if we are greater than that, we are at the 4, then we need to set it back to 1 to start from the beginning. So it will go with easy, normal, hard, easy. We create a local variable named level. We get the correct text from the difficulty levels table. Here, using the index, if our index is 2, it returns normal. Then we use GUI.setText to set the text of a text component. We had a difficulty text here under this. So we sent that node, and as the text, we concatenate two strings. If you use two dots, it adds strings to each other. Lastly, we set the game manager's difficulty as our new difficulty, because the difficulty level will also affect the gameplay slightly. Lastly, we have the return menu button to check if it is pressed. This is the reverse of the settings button. We set the current layer back to base. We enable the base layer and disable the settings layer. We also have our GUI script. We can also take a look at the GUI. Maybe GUI was not the best name I can come up with. Here we have a bunch of functions. This is our GUI. We have some screens and our game. This line is again game manager. We use the game manager on some occasions. On the init, we acquire input focus because we are a GUI script and we want to know when mouse is clicked to be able to detect the clicks on the screens. On our self table, we create HP and max HP variables. We use GUI.getNode to get the node we want to have, and the node we get is HP in. Then for our max HP, we get its full size because as you can see, it fills all of the bar. We have a floating text life variable. When you collect a loot, you will have a text on the bottom left corner that says you have looted this, and it stays on for some amount of time. So we will have this as a variable, and I have created a nodes table, and under it we have a bunch of nodes. One is for grenade. The grenade, of course, here is the text because we don't need to change the image. We have the bullet. For the bullet amount, we have the gun, which is the image of the gun we are holding. We have the loot text, the yellow text here, loot screen, this one. Under it, we have a try game button and return menu button. We have a win screen, and under it, we have start a game button and return menu button 1. At the beginning of the game, we hide the loot text, loot screen, and win screen. Same with the main menu GUI, we set our current layer to game. So when we are playing, even if we click here, it will not activate the button on the loot screen or the win screen. Then we call the update UI function. It is here. Now the reason why I have this function before the init function is because with Lua, you cannot call a function before you create it. So if you try to cut and paste it here, the function will not be recognized. So you need to have it before calling it. Now on our update UI function, we update two things. One is the gun part and the second one is HP part. This HP part is from the HP bar tutorial. Now let's first take a look at the gun part. We create a local variable named gun name. Then we check for the game manager.weapon number to see if it is 1. If it is 1, that means we are holding the pistol. If it is 2, we are holding the machine gun. If it is 3, we are holding the shotgun. And save it on the gun name. We will use this gun name to show the correct gun sprite. And we create a local variable named bullet amount, and on it we get the bullet amount from the game manager weapons. So let's say we have the machine gun, we will have 2 here. So on the game manager's weapon table, we will check for the 2. If you remember, it has its own table. So under it, we check for the bullet amount and save it here. Then we use GUI.setText to set the text of this part, which is the grenade amount. So we on the self nodes grenade, which is here, we set the text to grenade amount. We do the same for the bullet and save the bullet amount. And we use GUI.playFlipbook and send the shotgun, machine gun, or pistol as the new texture we want to display on the gun node. It was this one, gun, and this is the reason why we have the guns as animations on the other tile source. They have their own animation, machine gun, pistol, and shotgun. After we are done with updating the gun part, we can update the HP bar part. We first calculate our HP percent. For this, all we need to do is to divide the HP to the max HP. If you have 50 HP and your max HP is 100, 50 divided by 100 will be 0.5, and this math.min function will return the smaller value between the 0.5 and 1. Since 0.5 is less than 1, it will return the 0.5. So we will have 0.5, in other words, half HP. Then we create a new local variable named new HP size, and what we basically do is to multiply this HP ins x size by 0.5. Let's say I multiply this with 0.5. As you can see, we will have only the half HP. For the new size, we use vector math.vector3 to create a new vector. For its x value, we multiply the HP percent by the max HP to get the new size we need to have. For the y value, we just get the y value from the node itself, so it will not change, and our z value will be 0. We use GUI.setSize to set the size of the HP node, the new HP size. After we are done with this part, we check if the HP is less than or equal to 0. That means our player has died. So we first send a message to the scene parent, and on the message we say set the time step. We also send some variables. Here factor is important. Factor is the time step you will have on the collection. If you set this to 0, it will basically pause the game. So if we have died, we need to pause the game. Then we need to show the loose screen and enabling it with true. We also set the current layer to loose screen. So when we click on a button on the loose screen, we will actually be able to click it. Every time we call the update UI function, we will be updating the guns and the HP bar. We have a short update function. On the update function, our self.floating text life is greater than 0, which means we have looted something and the text is still visible. Then we decrease it by delta. With Lua, we can say self-floating text life minus equal to delta, unfortunately, so you have to write it as it is. After this decrease, we check if the text life is less than or equal to 0. If it is, that means we need to hide it, so we use GUI.setEnabled with false to hide it. Now we have two functions, one is onInput and the other one is onMessage. Let's first check onInput function. If we just left clicked, if we are on the loose screen, we check if we have just clicked the try again button. If yes, we first set the time step back to 1, so the game will move on and will not be frozen. And we send a change scene message to the scene parent. And for the scene, we send the current level we are on, because when you lose on a level, if you press the try again button, it will reload the level. If return menu button is pressed, then again we set the time step to 1 and send the change scene method, but this time for the scene, we send the menu as the variable. If our current layer is not blue screen, but it is win screen, we have finished the game, we have reached the portal at the end of the second level. Then we will have some new buttons. First one will be the try again button. No, it will be start again button. So if we are on the win screen and we click on the start again button, we will continue the game and change the scene to the level 1 to start the game. If where we clicked is on the return menu button, then we continue the game and change the scene to the menu. We are on our last message. OnMessage function is the function where we receive the message. So all of the messages here are sent from outside. So if something sent us a win message, then what we need to do is to freeze the game with the factor 0 on the set time step. We enable the win screen to show it and set the current layer to win screen. Update UI message is sent, then we update our UI. This will be sent from the layer. If the message is loot, we have looted something, then we check for a variable named loot type on the message. If you remember, when we post a message, we can send some variables too. And when loot message is sent, it will have a loot type variable. If it is HP, that means we have gained some HP. So we first get our current HP from the game manager HP. Then we add the message value to our HP. Let's say the value is 30 and you have had 80 HP. Then you will have 110 HP, but our limit was 100. We don't want this to happen. That's why we use math.min to get the correct value. If you have 110 here, and for the second variable, you send the max HP, which is 100, then it will get the smaller value, which is 100. So your HP will be kept at 100. Lastly, we set the HP on the game manager. The following three checks are the same. If we have looted a pistol, that means we have collected ammunition for the pistol. So we first get the correct bullet amount from the game manager's weapons table. We add our message value to our bullet amount and we set the bullet amount back on the game manager. We do the same for the machine gun and the shotgun. Lastly, if we have looted a grenade, then we increase the grenade amount by the message.value and set it back on the game manager. Since we have just looted something here, and we also set the floating text life back to 1. So if you loot a box and after 0.8 second you loot another one, the loot text will not disappear after 0.2 seconds because it will be set back to 1 after you have collected the second one. For the loot text, we start as you have looted, double dot to connect them, message value, which is, let's say, 5 pistols, and helper is used to have a proper name. So when we loot pistol, machine gun, or shotgun, we are not actually looting the weapon, but the bullet. So we send a helper value that says bullet. So at the end, it becomes you have looted 5 shotgun bullets. We enable the loot text and set the text as the text we have here. Lastly, since we have looted something, something has changed on our UI, so we call the update UI function. With this, we are done with the GUI scripts modules, and now we can continue with the scripts. Let's start with simple ones. Camera parent script. On the init, we use the projection of this camera. We get the player's position and set our position on the player, so camera will start the game with player centered. And on the update, we get our position, we get player's position, and we create a local variable named xy vector, which shares the x and y value with the player and the z value with our camera parent. And we use vector math.lerp to lerp our values to the new position, so the camera will follow the player, but since we use lerp, it will do it smoothly instead of sharp movements. Lastly, we use this position vector and set it as our new vector. This is the generic script I use for most of the tutorials. We have another simple script, which is decal parent. Decal parent only receives a message when some enemy dies. When it dies, it receives a message that says blood. We will use factory.create to create a blood stain on the map. Let me show you the decal parent. It has a factory, so we use factory.create with the factory we have. And for the position of the object we are going to create, we use message.position because when an enemy dies and sends this message, it will also send its position as pos, and we will use it to know where we need to create the blood stain. This is a print statement we don't need. Now we have also a simple script on portal. On the portal, we have a property You can set a property with GameObject.property, and for the first part, you set the name of it, and for the second part, you enter the value. You can have an integer, float, or boolean value here, but unfortunately, you can't have string values for the properties. It complicates things. Instead of having level 1, 2 as the value of the goal level, you will need to have them as integers and then convert into a string. The reason why we use GameObject.property instead of self.table, because then on the properties panel we will have our goal level property and we will be able to edit it on the collections. It was the components with blue marks, like loot boxes have this, and the portal should have a goal level property. On our portal, we have a collision object with its type set to trigger. So when something on the mask, which is player, collides with it, it will trigger this. And if the message group is player, which is not actually necessary here because we only interact with player, and this is similar to action.pressed. Message.enter is used to make sure the inner part is called only once. So this will only be called when player enters the collision, and it will not be called again as long as the collision keeps going on. If player has entered the portal, then we create a local variable named scene name. If the goal level is 1, the scene name needs to be level 1. For 2, it is level 2. If the goal level is 3, since we don't have a level 3, we will not be loading the new level, but we will send a win message to our GUI and we return, so these parts will not be executed. But for the level 1 and 2, we first play the sound on the portal with gain as 0.3, and we create a timer.delay. When you use timer.delay, it first waits the amount you have put here, so it will wait half a second. This false means it will not be repeated, and after this delay is done, this function will be called. Just create an empty function, like here, function end, and you can put whatever you need between them. For this case, we send a change scene message to our scene parent, and for the scene, we use the scene name variable we have set here. Now we can continue with bullet. Bullet script also has properties. I have just said we use properties so we can edit them on the properties panel, but this is not the only reason we have it. By open the player script and go to the bullet factory part, you will see that when creating a bullet, we will be sending some speed, attack, and direction variables, and they match to these names. So when creating a game object, if you send some variables with it, and if the object you are creating has those properties as game object property, they will be automatically set by the engine. And with this, we avoid sending and receiving message. If we initialize them on our cell table on the init function, then we would first create the bullet, then send a message to that bullet that has speed, attack, and direction values. And on the bullet, we would need to receive that message from the player and set the values, but it will be too much work. All we need to do is create some properties, and from the player we will be setting them easily. Now on our init function, if we have a direction value set, we use these lines to rotate the bullet towards the direction we are looking at. On our bullet, we have a collision object with trigger type, which interacts with default player and enemy groups. If a trigger response is received, that means we have collided with an object with one of the groups. We send a change HP message to the message.otherID. Message.otherID is whatever you have collided with. So we send change HP message to that object, and for the value, we send our attack power with negative value to decrease the health of the object. And we use GameObject.delete to delete ourselves. Now you may think the tile map is on the default group, but when we send the change HP message, what will happen? And nothing will happen. The message will be sent, but since it does not have an onMessage function, the message will not be used, so discarded. For the update, we basically do two things. We have a lifetimer variable, which is set to 0. Let's say you have somehow managed to shoot outside of the tile map, and the bullet will not be colliding with anything, no matter how long it moves, but we don't want it to fly forever. We want it to be deleted after some time, so it will free some of the memory. So on the update function, we increase the lifetimer by delta every frame. If our self timer exceeds 5, it means we need to delete ourselves because we haven't hit anything. If we do hit something, we will delete ourselves before that, so this part won't be executed as this will be all gone. If we still have some lifetime, we won't be deleted. Then we check if the direction was set when we are created, so we know where to go. Then what we basically do is we get our position, and to our position we add the direction we need to go as normalized. So its length will be 1, and we will multiply it by speed and delta to have a consistency between fast and slow devices. Lastly, we use GameObject.setPosition to set the position of the bullet to the new position we have just calculated. This was the bullet script. You can attach it to the bullet GameObject with add component file and selecting bullet. I have explained the camera parent and decal parent. Enemy and player is a bit complicated, so I will leave them to the end. Let's continue with the grenade script and also open the grenade game object. On the grenade, we have some properties like the bullets, so when creating the grenade, we will be able to set them easily. When we first throw the grenade, it will have some speed variable, and it will slow down till it stays still. It will happen with this deceleration value. We also have a local variable named explosion delay. This is the amount of time the grenade game object will wait after the explosion happens before deleting itself, so we will have enough time to see the explosion animation. On the init function, we create some variables on our self table. We have current speed, exploding, and enemies in range. We set the current speed as our speed property. For the exploding, we set it to false. Then we create a table named enemies in range, and it will be an empty table. And you throw the grenade, this trigger collision shape will detect enemies, and if an enemy enters here, it will be registered in this table. If the enemy exits, then it will be removed from the table, and when it explodes, it will only damage the enemies in the range. We send a disable message to our explosion component. It is this component, and when you disable it, you basically hide it. So we will only see the grenade at first. If the exploding variable is true, then we return, because we don't need to move anymore. We have already exploded. If we haven't exploded yet and our current speed is still greater than 0, then we get our position. We add the direction we want to go on, multiply it by speed and delta as we did on the bullet, and set the new position. Then we also decrease the current speed by deceleration and delta to make sure our speed doesn't reach a negative value and our grenade start moving backwards, we use math.max to get 0 or the value here. So if you end up with a negative value here on the second part, since 0 will be greater, then this math.max will return the 0 and our current speed will be 0. On the update, we also check for the life timer and we decrease it by delta. If we have reached 0 and we haven't exploded yet, then we call the explode function. On the explode function, we first set the exploding to true, so this function will not be called again. We enable the explosion sprite. This one, enable it back. We play the explosion animation on the explosion sprite. The default animation is already explosion. And we also play the sound component we have. It is the explosion sound. After that, we get our position and check for the enemies in the range. We first check if the enemy exists. We get our enemy's position. We calculate the distance from our grenade position to the enemy's position. We create a max range local variable set to 100. And for the damage, we do some calculation, which basically returns a greater value if you are closer to the grenade. So the closer you are to the grenade, the more you will be damaged. So if you throw a grenade to an enemy, but the enemy is at the border of the grenade, still in range, but far away, so it will not receive as much as damage from an enemy at the center. If after the calculation you end up with a damage greater than 0, that means enemy is close enough to hurt. So we send a change HP message to the enemy. We send the message to the ID of an game object. And for the value, we send the negative damage amount. Lastly, we create a timer delay with the explosion delay set to 0.5. We will not be repeating it, and the function we will be calling is this one, which deletes the game object. We will at least have enough time to see this explosion. Lastly, on the onMessage function, we check for trigger response because we have a collision object with type set to trigger, and it says enemies. We can again check just in case if the group is enemy, and if message.enter is true, that means the enemy has just entered this range. So we register it on the enemies in range table with the table.insert, and for the ID value, we save the enemy's ID. Here, maybe we could do as if and equals false instead of as. So if it is not entering but exiting, then we check if we have the enemy saved in the enemies in range. If yes, we use table.remove to remove the enemy from the enemies in range. So we can use this table when we explode here. Grenade is also done. We have lootbox script. It has some properties which we will use to modify them on the scene. It requires the game manager because it uses difficulty settings. It has a type variable that shows whatever we have looted. We have the value, so how many bullets we have looted. And we also have an isOpen variable because we only want to be able to open a loot box once. So after we open it, we will set it to false, so we won't be able to open it. On our loot box, we have a collision object with collision type set to trigger. So when something, which is player, collides with it, it has just entered, and if we are not open yet, so the box hasn't been looted yet, then we can continue. We first set the isOpen to true, so we will not loot the same box twice. We create box loot type and helper text variables. if self.type is 0, which was the initial type, we return because we have forgot to set the type on the scene. If the type is 1, that means it is a pistol and its helper text is bullet. Same with the machine gun and the shotgun. If the type is 4, it is HP, and the 5 is grenade. They don't have helper text because I can say you have looted 20 HP or grenade, but you have looted 20 pistol would mean something else other than looting bullets. So we use the helper text. For proceeding, we get the difficulty level from the game manager. Difficulty, if our difficulty is easy, we multiply our value by 1.3. If the difficulty level is hard, that means we will be granting less loot, so it will be only 85% of the original loot, and the normal will have the original amount. We use math.floor to turn the value to an integer in case these multiplications turned it into a float, because we don't want to see that we have 25.8 bullets. We only want to see integers here. We play the loot sound. It has the gain of 0.3. Its speed is 2 because I tried with 1. It was a slow sound for the looting. With speed set to 2, it sounded better, so you can change it as you like. We sent a loot message to our GUI, and if you remember, we have had some loot type, helper, and value variables coming from the message. After the message is sent, we play the box open sprite, so player will know he has collected the loot in the box. We also have the mouse cursor script. This is the crosshair that follows the mouse. We first acquire input focus because we want to know when mouse is moved, and we create a last mouse screen position variable as a vector on our subtable. We will be requiring the camera module because we want to convert the position we are on the screen to the real world coordinates. On the onInput function, if the action.x returns true, that means our action has a position value. If you press a key, it will not have a position value, but when I click with the mouse, it can be on anywhere on the screen, so it will have an action.x value. So this check makes sure we are only checking for mouse. So when the mouse is moving, we set the last mouse screen position to the actions x and y values. So we will have an updated last mouse screen position. On the update, we have our camera path. Maybe we can copy and paste it outside. Now we create two variables named world x and y. We use camera module and the screen to world function. From there, we send our camera path. We send the actions x value and the y value. This will return two variables and they will be saved here. We will use them to create a new vector named world position with world x and y values. Then we use GameObject.setPosition to set the mouse cursor's position on the world. Now you may think, why don't we just copy this and paste it on the onInput function? Because only calculating the position of the cursor when we move the mouse seems logical. It is, but at the same time, it causes problem because if you have it on the onInput function and you do not touch the mouse, use WASD to move around. Let's say you are going up, the mouse will not stay at where it is, but it will actually look like it is moving downwards, because when you move upward, the world position of the mouse will not change. We don't want this. So this is a proper way of doing it. Before enemy and the player, we only have the scene parent. Scene parent is the script we attach to our game object on the main collection, to this one. It handles loading, unloading scenes, and reloading scenes. It requires game manager and A star. On the init, we acquire input focus, which may seem unnecessary because we don't have any on input function. As I have said before, we use this when we need to use the on input function. But for this case, the scene parent is actually the parent of all of these scenes. And with default, if you want to be able to detect inputs, all of your parents still to the main collection needs to be able to acquire input focus, because even if they are not using it, they are passing it to their children. With scene parent, when we set this line, we are actually enabling the game objects under the levels to also be able to detect it. So we need this line. We have a next scene variable set to nil. We have an is reloading variable set to false. When we first start the game, scene parent will be initialized. So we set the current level to menu because we will start at the menu. Here, we reset the game and save the progress. So some of the empty tables on the game manager will be filled properly. Then we send our menu component, which is this one. And we say it load. When you send a load message to your collection proxy, it will load the collection. But just loading a collection is not enough. When you load a collection, you need to enable it. Thankfully, when a collection is loaded, it sends a proxy loaded message. So when we receive it, we will be enabling the sender, which will be the menu collection for this case. Before loading a new level, we call the load save function. So we will have consistency across levels. And we also just set the time step to 1 just to be sure, so the game will not be frozen. Now, if we receive a change scene message, and the message also has a variable named scene that is not nil, then we will call the switch to scene function with the new scene we want to be on. Before that, if we want to load the menu or the level 1, that means we are restarting the game, so we also call the game manager.reset game function. When switch to scene function is called, it checks if the new scene we want to load is the same scene as our current level. If you are on the level 1 and you want to load level 1, that means you actually want to reload the level 1. So we set the self.isReloading to true, and we send an unload message to our current level. This sharp means we are sending it to here, to let's say our current level is level 1, sharp level 1 is this collection proxy. When the collection is unloaded, it sends a message that says proxy unloaded. We only need to care about if a proxy is unloaded if we are reloading a level, because after unloading the level 1, we will need to reload it back. So we check if self.reloading is true. If yes, we first set it to false, so we will not continuously reload the level till it breaks the game. And we send a load message to our current level. If the new scene we want to load is different from the scene we are on, that means we are not reloading, we are just unloading the previous scene and loading the new one. So we first send an unload message to our current level because we have yet to change it. Then we change our current level to the new scene and load the new level we want to be on. When it is loaded, it will be enabled here. Before loading it, we also save the current progress. So when we load the new level, the progress we have saved here will be loaded back. We also have this a*set initialized false. On a new level, we want to be able to calculate the A* again because the map has changed. So where the enemies can walk on is different from the previous level. So we set the initialize to false. Thanks to this, when an enemy tries to set the A*, it will return true for the first one to try. And I think that's it with the scene parent. Now we only have two things remaining, the player and the enemy. Let's start with the player. Player will be using game manager, so we require it. We have a bunch of properties. Player will have a speed, direction, will have a can fire variable, so we will not shoot 100 times for one click, but we will wait some amount of time, which is the fire interval, and we will use the fire counter to count till the fire interval. When we reach it, we will set this to true. We have an attack power that changes with the weapons we use. So shotgun will have high attack power, but rifle will have low. We have a muzzle type, which is unnecessary. We have a can scroll variable. We use this so scrolling once will not switch weapons 5 or 10 times. We use this so it will be more responsive when we use it. We will again have a scroll counter and interval like the firing mechanic, so we can keep the track of it. These three are basically the same. Now on our init function, we acquire input focus because player will be using the keyboard inputs and mouse inputs. We first disable both muzzle, flash peak, and the small sprites, which are these ones, so we can have this effect. We start playing the sound on the level 1 from the player. I didn't want to create another script for the music, so I just call it from the player. It starts the background music with 0.1 gain. We call the change weapon function. Since we call it on init, it needs to be defined before the init. On the function, we first get a number variable from the game manager's weapon number. If it is 1, that means we are holding a pistol, so we use sprite.play flipbook on the gun sprite to play the pistol animation, so we will see the pistol. If it is 2, it is machine gun. For 3, it is shotgun. We set the muzzle type, fire interval, and attack power all from the game manager. And on the weapons, which is the copy of the default weapons, it has attack power, fire interval, and muzzle type. After we change our weapon, since we need to update the UI, we send an update UI message to our GUI, so the image on the GUI can also be updated. On the update function, we count here. If we cannot fire, then we first increase our fire counter by delta, and if we have waited enough for the fire interval, that means we can now fire, so we set this to true, and we set the fire counter to 0. We do the same but for can scroll, and with scroll counter and scroll interval. We wait 0.2 seconds if I am not wrong. We wait for 0.2 seconds, and after that we can scroll between weapons again. If our direction is not normalized, we normalize it. We get our position, and to our position we add our direction multiplied with speed and delta as we did on the bullet and grenade, and we set the new position. We reset our direction. Why we do it? It's because of the part here. And this is the part where player follows the mouse cursor and look at it. We get the cursor position from the mouse cursor game object on the level 1 or 2. To get the direction, you can subtract your position from the target position. We use math function to get the angle to the direction, and we use GameObject.set rotation with the new angle to look at it. Now on the onInput function, if we press R, it will send a change scene message to the scene parent with the current level. Since we are on the current level and we try to load the current level, the script will know we are trying to reload the level, so it will reload it. This is the part where WASD is used. If we press A, then our X direction will be -1. If we press D, our X value will be 1. And for up and down, we set the Y to 1 and -1. But as you can see, we only set the value to 1 or -1 here. We do not set it to 0 when we are not pressing. So after using the direction to move around, we set it to 0 here. On the onInput function, if the action is not a movement action or reload action, then it can be a left click where we pressed. When we use the left click, we will be shooting. So we check if we can fire and if the weapon we are currently holding has at least one bullet we can shoot. If these are true, we first set the snap that can fire to false, so we cannot shoot twice in a row. We subtract 1 from our bullet amount. This is actually like here, but the line is too long, so this is easier to see. We create a local variable named muzzle sprite, and if snap.muzzle type is small, then the muzzle sprite will be muzzle flash small, which is this sprite. If not, it will be the big. We send enable message to the muzzle sprite, so it will be visible. We also use timer.delay with 0.1 seconds, and we send the same message but with disable. So after 0.1 second, it will disable the sprite back, so it will be a flash. If our current weapon number is 1, that means we are using a pistol, so we will play the pistol sound. If it is 2, we play the rifle sound, and for 3, we will play the shotgun sound. Since we have handled the visuals and audio, then we can calculate the bullet spam logic here. We get our position, we get the cursor position, and we subtract our position from the target position to get a direction towards the target. We create a right vector, which is the right of the direction. If you use factory.create, the created object will be spawned on the center of the player. But we don't want this to happen, so we shift it by some amount to forward, but even this isn't enough because the gun isn't here but on the right side. So since this is our direction and the right shows the gun, we calculate the right vector and add some amount of it to get to the gun point. You can disable some of these lines and test to see how it looks. The spam offset we need to apply is the direction times 16 plus right times 9, so it will be shifted by 16 units to the forward and 9 units to the right. And the position we will spam the bullets is our position plus the spam offset. Now we have a check for the weapon number being 3 or not. If our weapon number is not 3, that means we either have the rifle or the pistol, so we can just use this part. We use factory.create with the bullet factory. We send the speed, attack, and direction values. But for the shotgun, we are shooting 3 bullets, so we will have an angle offset. I want the offset to be 10 degrees, so one of the bullets will go forward. The first one will be 10 degree to the left, and the third one will be 10 degree to the right, so they will spread. We have our left rotation and right rotation from the angle offset. We calculate 3 different directions for 3 different bullets and save them on a table. Lastly, for the pairs in the directions, we call this factory.create with the direction from the directions table. So we will create a bullet, its direction set as their left, one with their right, and the last one will be their right. After we shoot a bullet, we need to update the UI, so we will know we have spanned a bullet. So we send an update UI message to the GUI. If the action is not left click but right click, that means we will be throwing a grenade. So we check if our grenade amount is greater than 0, then we decrease it by 1. we get our position, cursor position, and calculate the direction. Then we calculate with a grenade offset, spawn the grenade from here. For the grenade position, we add the offset to our position to know where it will be spawned. Then we use factory.create with grenade factory. Create the grenade on the grenade position. We set the speed and direction values of the grenade. And again, we update the UI because we have used a grenade. We also check for scroll up and down. If it is scroll up and we can scroll, then we first set the can scroll to false. We increase the weapon number by 1, but we make sure we don't go out of the boundaries of the weapons table because we only have 3 weapons. If the weapon number shows 4, that means we need to set it back to 1. We will go back to the pistol after the shotgun. And we call the change weapon because our weapon number has changed. We do the same with the scroll down, but on the scroll up, we increase the weapon number, while with scroll down, we decrease it. Again, change weapon is called. Lastly, we have an onMessage function, which only checks for the change HP function. This will be sent from the bullet player is hit with. It will have a value. We add it to our HP on the game manager and change our HP. After that, we update the UI to see its effects on the HP bar. Player is also done. Lastly, we have our enemy script. Enemy uses A* pathfinding algorithm. First, let me explain how enemy works. Let's take a look at this enemy because it's on a unique position. This green circle is a trigger collision shape, and when player enters here, player in trigger value will be set to true, but the enemy will not see you unless enemy actually can see you, like visually, because we are also using raycast from the enemy to the player, and if there is an obstacle between you, enemy will not be able to see you. Enemy will start chasing you under 2 circumstances. If you are in this area and enemy can actually see you, then it will start chasing you. Or you are outside of this area and shoot the enemy is able to see you, then enemy will start chasing you. Once the enemy starts chasing you, it will chase you until you exit from this circular area, and also the enemy cannot see you. So let's say enemy is chasing you and you are here. Even if you are out of the range, enemy will still be able to shoot at you because enemy can see you. So you will need to hide somewhere here so enemy will not be able to see you and you will not be in range. This is a complex AI compared to any of the enemies I have shown on this channel. Now most of the parts here are for the A* algorithm. We have a speed variable for the enemy. Tile size will be used for the A*. If we go to the level 1, go our tile map, you will see that I have scaled it up by 3. So we will have a bigger map. Now if we go to our enemy script, we will see that tile size is 48, even though we are using tiles with 16 pixel size. But this is actually 16 times 3, because 16 is our actual tile size, while 3 is the scale we have applied. We are requiring the A* and the game manager. We have some helper functions, screen to course function, where you send a position on the screen and it gives you the tile coordinates you need. In this function, you enter the tile coordinates and it returns where it corresponds on the screen. We have a function that checks is walkable. We can add the tile equals 27 here too, which basically gets the tile you enter here and checks if it is a tile we can walk on. So we will use this when player is on a tile that enemy cannot walk on. We have a raycast can see player function. It gets enemy's position and player's position. And we use physics.raycast to cast a ray from enemy's position to the player's position. And these are the groups we will collide with. So the raycast will see the player and default group. Default group is important, so player will not be able to see you through the tile map walls because it was on the default group, and we also need to be able to see the player to be able to detect it. We get our player ID hash by hashing the path of the player on the collection. We check if the result returns true, and its ID, the thing it has collided with, is the player ID. So we can actually see the player. Now on the init function, we try to set the A star. We get the map height and width using tilemap.getBounds and use the tile map on the collection, which is this one. Then we use A star dot setup A star, and we try to set the A star. If A star is already initialized, then this line won't do anything. If not, we will initialize the A star. Now we will have a bunch of variables. We will have a target variable, current path, target index, player in trigger, and can see player. I can get this to here because these are the follow logic. Like the player, we will have some fire interval and can fire variables. We will have an HP. Enemy doesn't have a max HP because enemies don't heal in any way with this game. But if in your game enemies can heal, then you will need to have a max HP variable too. We get the difficulty level from the game manager. If the game is easy, we increase the fire interval of the enemies so enemies will shoot slower. We will decrease its HP. We will also reduce the power its bullet has. If the game is hard, then we make the enemies shoot faster, their HP will be higher, and their bullet also hurt more than the normal one. We hide the small flash muzzle because we only have the pistol with enemies. On the update function, we get player's position and our position is enemy position, and we check if we can see the player using raycast can see a player function above, and we set this. Here we check if we cannot see the player and we are actually chasing the player and it is not in the trigger area. We set the chasing to false. If player is in the trigger area and we can see the player, but we are not chasing the player yet, then we set the chasing to true. If we are chasing, we get our look direction by subtracting our position from the goal position. We get the angle we need to apply and set the rotation to make the enemy look at the player. We create a local variable named distance to player. We calculate the distance from player's position to our position. Now let's say we are chasing the player and either of these are true. Either we are greater than 100 pixels away from the player. That means player is far away, so we can get close to the player. Or we cannot see the player because player is around the corner. That means we need to move towards the player using A star. So we get enemy's position and player's position using screen to coordinates. This will get the global position of the enemy and the player and turn them into coordinates on the tile map. Here we check if we don't have any target or player is not at our target position. He is far away from the point we want to go. This happens when you start chasing the player and player is here, but player moves to that side. So now since player is not on the same place and the distance from our target to the player is greater than the tile size, that means we need to do some new calculations to know where we need to go. Then we check if we don't have a current path or our target index is greater than or equal to 0, or we have a current path but its size is 0. That means under these circumstances we need to recalculate our current path. Then we check if where the player is walkable, we can actually go there. Then we create a path variable and use a*find path to see if there is a path we can use to get to the player. If there is a path and path size is greater than 0, then we set the path as our current path. We set the target index back to 1, and for our target, we use the tile map coordinates to the screen and know where we need to go. If we don't have a proper path returned, then we set the current path as an empty table, so this will return as 0 next time we check. After this, assuming we have a current path that is not empty and our target index is not greater than our current path's length. Let's say you have a path with length of 10 and your target index is 5. That means you are halfway to where you need to be. But if you are already at the 10th position at the end of the current path, you can't go to the 11th path because it doesn't exist. We calculate the next tile we need to be on using the target index, and next position uses the tile coordinates and turns them into vectors on the screen. We get our direction again by subtracting our position from the target. Then we use GameObject.setPosition to set the position of the enemy to the new position, which is direction times speed and delta added to the current enemy position. If we have reached our next position, our distance to it is less than 2, and we increase the target index, so next time when we check for the next tile, this target index will be increased by 1, so we will be looking at a new tile. We have an else here. This is the else of this if. So if we are not chasing or our distance is less than 100, or we can actually see the player, that means we don't need to move and we can shoot from where we are. So we set the current path to an empty table, we set the target to nil and target index as 0. And this is the A star follow-up logic. Here we check if we cannot fire, same with the player. Then we increase the fire timer by delta. Then if our fire timer is greater than equals to fire interval, that means enemy has waited enough to fire again. So we set the fire timer of the enemy to 0 and can fire to true. If we can fire and we are chasing and we can see the player, then we will be firing at the player. But first we set the can fire to false, so this will only be executed once. We calculate the direction, we get the right as we did on the player. We calculate the spawn offset and bullet position. These are the same with the player. We enable the muzzle flash, and after 0.1 second we will disable it by sending this message. Then we use factory.create with the bullet factory and spawn the bullet on the bullet position with the correct properties. On this game, enemies can only use pistols, so there is no more additional check. But if you want with your game, you can copy the player logic to here. You will need to make some adjustments, but you can think this as a training. And if you have any question, you can ask on the comment section. With this, you can have different type of enemies. You can set them randomly, or you can have a game object property name enemy type, and you can set it on the editor to have more control over enemy behavior. After the update, we only have the onMessage function. On the onMessage function, we check for two messages. One is the trigger response and the other is change HP. If we receive a trigger response, that means player has entered this area. We check if player is entering. That means player is in trigger is true. We also need to check if we can see the player. So if player enters here and there is no obstacle, that means we need to start chasing him. So if we can see him, we start chasing. If message.enter is false, that means player is exiting. So we set the isInTrigger to false. We do not set the isChasing to false because we may still be able to see the player even though he is not in the trigger area. So we can keep chasing him. If we receive a change HP message from the bullet or the grenade, then we add the message value to our HP. Since we send negative message, this will decrease the HP of the enemy. If the HP is less than or equal to 0, that means it needs to die. So it will send a blood message to the decal parent, and for the position where the decal needs to be spawned, it sends its position. After that, it deletes itself. Then we start chasing, because even if you are outside of the enemy's range, if you shoot at him, enemy will start following you. And that's it. That's how you can develop a top-down shooter with Defold. You can download this project from my itch.io page, Asatta Games. You can find the links of the previous tutorials on the comment section. If you have any question, recommendation, you can ask on the comment section. If you liked the video, you can like and subscribe. Thank you for watching and have a nice day.